So today we're talking about VLANs, virtual local area networks. So VLANs are logical connections with other similar devices. So placing devices into various VLANs have the same following characteristics. So just like LANs, you're going to see a lot of similarities between LANs and VLANs, except LANs are done in the physical world and VLANs are done in the virtual world via the switch. So just like we saw in local area networks, it does provide segmentation of various groups of devices on the same switches. It can also provide organization that is more manageable. Things like broadcast, multicast, unicast are all isolated within an individual VLAN, just like we saw that they were isolated in an actual physical LAN. Each VLAN will have its own unique range of IP addressing, so each VLAN needs its own subnetwork, just like each LAN did. And again, smaller broadcast domains. So VLANs are based on logical connections instead of physical connections. But all the parameters that you've learned about local area networks, meaning they need their own subnetwork for each VLAN. Everybody in that VLAN has to have the same network number, the same subnet mask, the same default gateway. All the parameters that you've learned about local area networks in Cisco 1 still hold true in virtual local area networks in Cisco 2. So benefits of doing a VLAN. Again, you have a smaller broadcast domain. So by dividing your LAN, it reduces the number of broadcast domains. Improves security. Only users in the same VLAN can now communicate with each other. The only way that individuals in other VLANs can communicate is still through a router. You have improved IT efficiency because VLANs can group devices with similar requirements like faculty versus student, software parameters, something like QuickBooks that is very small as opposed to graphic software which is very large. So again, you can group them according to device, according to location, according to department, just like you did with local area networks. Reduce cost. One switch can support multiple groups or VLANs. For the most part, the roundabout number is about 4,096 VLANs that can be supported. The number of supported VLANs has to do with the particular model of the switch that you have. And simpler management because smaller groups will need similar applications and other networking resources. So again, you could disperse your bandwidth according to what each department or each VLAN needs to operate. Now there are different types of VLANs. Your default VLAN, as you learned in Cisco 1, was VLAN 1. It is the default VLAN. It is the default native VLAN, and we'll talk about that in a little bit. The default management VLAN as well for remote access, and it cannot be deleted and it cannot be renamed. So while we cannot delete VLAN 1, Cisco will recommend that we assign these default features to other VLANs for security purposes. And again, we'll talk about that going forward as well. Also, what you see on this slide, the ranges of 1002 up to 1005 are also default and cannot be deleted and cannot be renamed. Your data VLAN is dedicated to user-generated traffic, so something like email and web traffic. VLAN 1, again, is your default data VLAN because all interfaces by default are assigned to this VLAN. Your native VLAN is used for your trunk links only. And we'll talk about what a trunk link is as we go further along. All user traffic frames are tagged on an 802.1q trunk link, except for those in the native VLAN. Untagged traffic is generated by a switch. It may also come from legacy devices. It can also come from things like different protocols, services, things of that nature. So anything that is untagged is going to flow through that native VLAN. So the 802.1q trunk port places untagged traffic on the native VLAN. Then you have your management VLAN. As you learned in Cisco 1, your management VLAN is used for SSH and telnet traffic and should not be carried with end user traffic. So this is why we say that we should separate VLAN 1, which is your default management VLAN, with VLAN 99. Now, typically the VLAN that is the SVI for the layer 2 switch is the one that acts as the management VLAN. So your voice VLAN is a separate VLAN. It is required because voice traffic requires assured bandwidth. So think about quality of service. Assured bandwidth, high QoS priority, the ability to avoid congestion. It needs a delay that is less than 150 milliseconds from source to destination. So the entire network has to be designed to support voice. Now, VLAN trunks allow all traffic to propagate between switches. Now, this enables devices connected to different switches but in the same VLAN to communicate without going through a router. So very important process again. Without a router, VLANs on different switches cannot communicate with other VLANs outside of their own. So in this example here, you can see that I have VLAN 10 on this side, and I have VLAN 10 on this side, as well as 20 here, and 20 here, and 30 here, and 30 here. So the premise is, those that are in the same VLAN can have inter-VLAN communication. So anybody in 10 can talk to anybody else in 10. Anyone in 20 can talk to 20, etc. However, 10 cannot talk to 20, and 20 cannot talk to 30, etc. Okay, so inter-VLAN without a router is not possible. Now, your trunk is a point-to-point connection between two networking devices. So whenever you see your switches like this is a trunk port from here to here. Your trunk port is an avenue. Oops. So it is an avenue for passing traffic. Okay, it allows more than one VLAN. It will extend the VLAN across the entire network. By default, it supports all VLANs, and it also supports that 802.1 trunking. So without VLANs, all devices connected to the switches will receive all unicast, multicast, and broadcast traffic. So without a VLAN, if this were just a regular network where all of the devices were on the same network, everybody, it's one big broadcast domain, okay, also one big collision domain, and everything would be passed to everybody on this particular network, except for the one that it was received on. So with VLANs, unicast, multicast, and broadcast traffic is confined to a VLAN, again, because your VLANs will confine it to a particular area. VLANs carry the same significance as a LAN. So without a layer 3 device to connect VLANs, devices in different VLANs, again, cannot communicate. However, your traffic is confined to a single VLAN. So as you see here, again, I have VLAN 10 and VLAN 20. And my VLAN trunks are configured to support both VLAN 10 and VLAN 20. So the devices in VLAN 10 that are on switch 2 and switch 3 in the same VLAN can talk to each other. The devices in the same VLAN and VLAN 20, regardless of where they are plugged in, can also talk to each other. However, VLAN 10 cannot talk to VLAN 20. So identification with a tag. So when we incorporate VLANs, you have to understand that there still has to be some feature, some way that a conversation is tracked, that it can go back to the generating source. That is that VLAN identification with a tag. So the IEEE 802.1q header is 4 bytes long. So as you see in this example, excuse me, that tagging feature happens right in between where you have your header information here. So this is my data link header information. My destination source MAC addresses. Here is my tagging right here. So this tagging identifies what VLAN is generating the information. This is how, again, they keep track of a conversation. Excuse me. So when the tag is created, the frame check sequence must be recalculated. When sent to end devices, just before pushing it out to the actual destination device, that tag is removed and the FCS is recalculated back to the original number. Because don't forget what we know about the FCS. It holds that CRC field or value. And so those values still have to match at the destination that were generated in the source to be considered valid information. So this tagging is used just for tracking from source to generation. Excuse me. So within this frame of information we see, your type field is a 2-byte field with a hexadecimal of 0x8100. This is referred to as a tag protocol ID or a TPID. You have a user priority, which is a 3-bit value that supports prioritization. Then you have your canonical format identifier, your CFI. This is a 1-bit value that can support token ring frames on Ethernet networks. And then you have that VLAN ID, which is referred to as a VID. It is a 12-bit VLAN identifier that can support up to 4,096 VLANs. So, 802.1 trunk basics. Tagging is typically done on all VLANs. The use of a native VLAN was designed for legacy use, like the hub in this example. Excuse me. So unless changed, VLAN 1 is always going to be the native VLAN by default. Both ends of your trunking line, however, must be configured with the same native VLAN. Each trunk is configured separately, so it is possible to have a different native VLAN on separate trunks. The only parameter is that each connection of that trunk has to be the same native VLAN. So between here and here, between here and here, here and here, and here and here. For whatever reason, if you decided to name your VLAN trunk something different for whatever design feature that is going to be conducive for you, you could certainly do that. But you have to understand that by default, your switches already have VLAN 1 as your native. So if you're going to go in there and change it to anything else, then you need to be aware that you need to change that on the other side of that connection as well. Now your voice VLAN tagging, your VoIP phone is a 3-port switch. So the switch will use CDP, Cisco Discovery Protocol. You learned a little bit about this in Cisco 1. It's going to use CDP to inform the phone of the voice VLAN. The phone will then tag its own traffic and can set a cost of service. You'll learn about cost of service, priorities, things of that nature in your next course of Cisco 3. So this is more of an FYI slide for me, just for your information. We're not going to do anything with voice over IP or any kind of voice VLANs in this course. Your cost of service is a QoS for layer 2. The phone may or may not tag frames from the PC. So your voice VLAN is tagged with an appropriate layer 2 class of service priority value. This is something that you're going to learn how to generate when you get to Cisco 3. So in Cisco 3, now you can take your traffic, you can say all of your data, whatever type of data. You can classify your type of data as far as service and as far as priority to value. So once your device gets that information, it can simply refer back to the cost of service and the priority that you gave that particular piece of data, and it will automatically treat it as you have chosen. Your access VLAN can also be tagged with the layer 2 COS priority value. Again, priority is how important is this to your organization. And your access VLAN again is not tagged, so no layer 2 COS priority value is added. Now your voice VLAN, in order to verify, you show interfaces and then you look at the particular interface that you have utilized for your voice traffic. The only difference that I want you to take away from voice in this course, there's a whole entire course based on VoIP, voice over IP, is as you see in this output, your voice VLANs need to utilize 2 different VLANs. They have a voice VLAN, which is a standard VLAN of 150, and then they have an access mode VLAN, in this case 20 for the student VLAN. Now your VLAN ranges, there are VLAN ranges on your Catalyst switches. So your Catalyst switches 2960 and 3650 support over 4,000 VLANs. So when you do a show VLAN brief, as you see up in the right-hand corner here, this is the information that you will gather. By default, every single port on this switch is in the native VLAN that is 1. So in reading this, you're going to see, obviously, when you look down at the dynamic, this is your VLAN, so VLAN 1. This is the name of the VLAN, which is default. Those parameters cannot change. It is inherent to the iOS on the switch. All of these ports are all active because the ports in your switch are on by default, as opposed to your routers, which are off by default. And this switch has from F1 to F24, and then it also has 2 gigabit ports. Now, your normal range from 1 to 1005 are reserved for legacy VLANs and they're in your running config. They are used in small to medium-sized businesses, used by service providers. Oh, you're extended. I'm sorry. I'm mixing up my parameters here. I apologize. The first part of the slide, your normal range from 1 to 1005. This is used in small to medium-sized businesses. 1002 to 1005 are reserved, which is why you can't touch them. You can't change them. 1002 to 1005 are auto-created and cannot be deleted or renamed. They are stored in the VLAN.dat file, which is in your flash. VTP, which is a pruning protocol that we'll talk about, can synchronize between switches. In your extended range, which is 1006 to 4095, this is used by service providers. It is running in the running config. It supports fewer VLAN features, and it also requires VTP configurations. So VLAN details, again, they are stored in a file called VLAN.dat. You create VLANs in global configuration mode. So as you see on the slide, you're going to enter into global configuration mode. So from your switch privilege mode, You're going to do configure T. Then you're going to create your VLAN. So don't forget the dynamic that you learned in Cisco 1 about what is your command and what is your keyword or argument. Okay, so anything bolded that you see here on the slide is your command. So here, VLAN is my command. VLAN ID is either a keyword or an argument. And remember back to Cisco 1. If it is a keyword, it is embedded into the iOS. Meaning it is simply part of the iOS configuration. An argument is something that we, the administrators, create. So what is my VLAN number here? If I choose VLAN 10, that is my argument. Okay? If I do ping, ping is my command, 192.168.10.1, who is the destination I want to ping, that is my argument. So again, a keyword is already embedded in the iOS. Show protocols. Protocols are part of the iOS. So do know the difference there. After that, you need to name this VLAN. Give it something substantial and unique that you understand. After that, you type in end and you get back to config T in global mode. Now, your VLAN creation is very simple. If the student PC is going to be in VLAN 20, we will create the VLAN first, and then we will name it. So again, just like the previous slide, config T, VLAN 20 as the example, the name is the student VLAN, and then I say end. If you do not name your VLAN, the iOS will automatically name it for you. And it will give it a default name of VLAN and the 4-digit number of the VLAN. So as you see here. So if I simply go in and create VLAN without naming it, in VLAN 20 in this example, it's going to name it VLAN 0020 for VLAN 20. Now, can you go in there and rename it? Yes, you can. Okay, but if you forget to name it, the iOS is automatically going to give it this default dynamic. Once the VLAN is created, then we have to assign it to the correct interfaces. So again, I go into my global mode, I go into the interface. So when we assign it, this term here, we can then assign it to the correct interfaces. I am then taking my interfaces from my switch and identifying which ports belong to which VLAN. This is why now it becomes very important where you plug information in, because it is port specified, so you have to plug it into the port. So in the previous example, my previous example was VLAN 20 was for my students. So now again, what we gain in VLANs or utilizing VLANs is we don't have to be globally in the same area like a local area, not globally, geographically, excuse me. We don't have to be geographically in the same area like we had to in a LAN. So if I have a switch here on the first floor, and I have a switch here on the second floor, and I say my student VLAN is VLAN 20, and I say VLAN 20s have ports 10 through 15. Again, I have VLAN 1, which would be my management. Then I have 2, etc. And then I can have, 10, 11, etc. So I'm on 2 different floors here. So in order for those 2 devices to be in the same VLAN, I have to make sure that they are plugged into one of those ports. So that's a student, that's a student, that is a student, and that is a student. Now, if I go in there and I inadvertently, because I'm not really sure about what I'm doing, or just make a mistake, and I plug a student into this port, oops, student, that student would not work, because I have identified my student network or my student VLAN to be that of the ports of, oops, I'm sorry. So if I plug this student in here into port 2 is not part of what I identified as my ports. Okay, so what we gain in VLANs is I can have them located throughout campus. Okay, I just have to make sure on each switch that my switch has the appropriate VLAN set up for the appropriate what? Department, communication, whatever I may say. I could say that all of my printers, which we do here at CCRI, all of my printers are on VLAN 65. VLAN 65 is going to be, let's say, ports 5 to 9. So on every single one of my switch in port 5 to 9, I would have to plug in my printer. If I plugged my printer into any other port that was not 5 or 9, it would not function. So now, again, it becomes very important as to where we plug in our devices. Now, once we decide our VLAN dynamic, then we have to move the appropriate ports into that VLAN, and this is how we do it here. We enter global, we enter the interface number. So again, if I'm talking about students and I have said that my student VLAN 20 is going to be 10 to 15, then I would go into interface 10. I would say switch port mode access. Access means to pass data. And then, so first thing you do, you define the mode. Your ports can act in 3 different modes, and I'll go over that in 1 second. So you define the mode first. Then after that, you say, okay, your switch port, you're in the access mode, and you belong to, in this example, VLAN 20. And then you hit N. So now what you've done on whatever switch that you happen to be on, and you would do this consistently on all switch unless you're using a server model, which we'll learn a little bit about in Cisco 3, I believe. For now, you're doing everything manually on each switch independently. So now I would go into switch 1 and put all those ports into VLAN 20. I would go into switch 2 and put all of those ports in VLAN 20. So we can assign the VLAN to the port interface. And again, this is an example just like what I just did on the board. Once the device is assigned to the VLAN, then the end device will need the IP address information for that VLAN. So here, the student PC receives 172.17.20.22. So meaning it is part of VLAN 20. So this is my VLAN 20 number. So that student has to be part of VLAN 20, and it is plugged into F18. So again, I went into interface F18, and I said switch mode access, and you are part of VLAN 20. So now, this is my subnet for VLAN 20. So that student has to be in that particular VLAN. Now with data and voice, and again, don't get too weighed down with data and voice. That's a whole entire separate course that if interested you could look into taking. Just understand that an access port may be assigned to one data VLAN. However, the only exception is voice. Voice needs a data port, and voice also needs a voice, not a data port, a data VLAN, and also a voice VLAN. So when you go into the configurations, as you see here, I create VLAN 20, I name it student, I create VLAN 150, I name it voice. Now I go into interface FA18, and FA18 gets assigned to both. That is the only parameter that I want you to take away from your voice network. So if I want to see my VLANs information, I could do a show VLAN summary, which is going to tell me the number of existing VLANs, the number of existing BTP VLANs, the number of existing extended VLANs. I could also look at the particular interface. So I could go into show interface VLAN 20 itself, and it will tell me everything about that VLAN. Now, if I want to display a VLAN name, status, and its ports, one VLAN per line, I would use the brief command. If I want to display information about the identified VLAN ID number, I would use the ID VLAN command. If I want to display information about the identified VLAN name, I am going to use the VLAN name, which is an ASCII string from 1 to 32. And if I want to display a VLAN summary of information, I will use the summary as you see here on this slide. If I want to change a VLAN port membership, there are a number of ways to change this. I can re-enter my switch port access VLAN and change the VLAN. I could also use the no switch port access VLAN to place the interface back into VLAN 1. So if I'm going to remove an interface or remove the interface from a VLAN, I can simply say the no switch port access VLAN on the particular interface, and as you see here, by default, it will go back into VLAN 1. Okay? Down here, if I do show interfaces for this particular interface, again, it is an access mode still, but it now belongs back to the default VLAN of VLAN 1. This one's trickier. If you're going to delete a VLAN, you delete the VLAN with the no VLAN and then the actual VLAN number. However, before you delete a VLAN, you need to reassign all the member ports. If you simply delete a VLAN for whatever reason and you leave your ports in it, those ports are still bound to that particular VLAN, meaning they are inactive and they cannot pass data. They also do not go back into the default because they are still held from whatever VLAN you had originally put them in. So best practice, if you need to delete a VLAN for whatever reason, you need to reassign those ports. Even if it's just no switch port and it goes back into the default VLAN of 1. You cannot leave them under a VLAN if you plan on deleting that VLAN because they are inactive and cannot be utilized. Okay? And you won't necessarily see it if it's not something that you're looking for. So that's one of the things that Lab 346 will show you. It will show you that when you delete something, then all of a sudden you're looking for that particular port. It's not in the default VLAN. And you deleted the VLAN that it was in, so you can't see a particular port. And that is because you did not remove it from the VLAN prior to deleting the VLAN. Now, if you want to delete the VLAN database in totality, the command is either delete flash :VLAN.dat or delete VLAN.dat. This now becomes something that you need to do when you are erasing your configurations on your devices going forward. You need to get rid of that VLAN database, because even if you do an erase start and a reload on your switch, this is held in flash. It will be there. It will stay there. So you have to delete the flash VLAN.dat or delete VLAN.dat to get rid of that database. After you do those commands, you want to reload the switch and then obviously say no to saving the configuration. To restore to the factory default, you want to unplug all data cables, erase the startup config, and then also delete the VLAN.dat, and then you're going to reload the device. Those instructions are in your lab. They are also pasted on each desk in your lab environment between your two PCs. Now, trunk configuration. Again, you go into global mode, you choose your appropriate interface, and then the command is switch port, and now my mode is trunk. So a trunk port is an avenue. Okay, so if I had multiple VLANs on my switch, so this is my default VLAN 1, then I have VLAN 2 here, VLAN 3, these are not port numbers, these are VLANs. Then 4 is going to be my trunk. 4 is going to go to my router or my layer 3 switch. That is my trunk. And then I have VLAN 5, etc. So your trunk port, because again your VLANs act the same as LANs, your VLANs, in order to have inter-VLAN communication, I need a router or a layer 3 switch. So this would be VLAN 2, this would be VLAN 3, this would be my trunk, which is port 4, and then VLAN 5. So if VLAN 2 wants to talk to VLAN 5, it still has to go through my router. My router still looks at the destination IP address and says, oh, hey, this goes to that VLAN. So I still need either a router or a layer 3 switch. So a layer 3 switch, because a layer 3 switch is capable of switching and routing, and you'll learn about that in upper level studies. Okay, so for now we are just going to be using a router as that device for inter-VLAN traffic between different VLANs. Again, my commands: config T, interface, the interface ID number, switch port, mode trunk, switch port trunk, native VLAN, and then the VLAN number. Then, now this one is optional but suggested, I can actually tell that trunk port which VLANs I'm going to allow. So if I have multiple VLANs in this example here, I could tell that trunk port, okay, you can allow VLAN 2, VLAN 3, and VLAN 5. And then to return to the privilege exec, you type in end. So the subnets associated with each VLAN in this example are VLAN 10, which is identifying the faculty and staff, VLAN 20, which is identifying the students, VLAN 30, which is identifying a guest. Now, and then 99, which would be the native. There is no dynamic. Okay, you decide how you want to assign your subnets, just like you do in a LAN situation. However, for teaching purposes, we suggest that you keep everything the same. So, My VLAN 10, which is my faculty and staff, I'm going to keep my subnet to 10. So my subnet is 172.17.10.0. And when I look at all my addressing is going to start with the 10 dot whatever network. So you want to keep it consistent. So I am VLAN 10, I am in the network 10, and so my addressing for my faculty come from the network of 10. Likewise, I am VLAN 20, my network I'm using 20, and my addressing comes from the 20 network. Again, my 30 network, my addresses are coming from 30. And then my VLAN 99, which is my native. And my network of 99. When you're starting out, stay consistent with this parameter, okay? It's going to help you to understand better when you're initially starting out. So port F0 on S1 is configured as a trunk port. Now, again, remember your trunk port has to be configured on both ends. So this FA01 here has to be configured for a trunk, as well as this FA01 here. They both need to be configured. If not, you will have a trunking issue and your information will not pass. Okay, so you need a trunk so that VLANs or hosts in the same VLAN but on separate switch for them to talk, you need to have a trunk. The trunk is your avenue. Okay? So again, I go into interface FA01, switch port is my command. Mode is telling your port how you want it to act. There are 3 different modes. So you have the access mode, meaning you're passing data. You have the trunk mode, which means you're passing traffic. And then thirdly, you have the routed mode. Your routed mode is telling the port to act like it is a router's interface. Meaning that by default, we do not give our switch ports IP addresses, do we? No. The only port that gets an IP address in your switch is your virtual VLAN. Okay, so VLAN 1, go back and remember what you did in Cisco 1. Interface VLAN 1 gets an IP address, a subnet mask, a default gateway if appropriate, for remote communication, for SSH and for Telnet. Normal parameters, even you see when you're doing a switch port mode trunk or switch port mode access, I'm not giving them an IP address. I can only give them an IP address if I tell them to act like a router's interface, because we do, on our router's interface, give them IP addresses and subnet masks. Okay? Routed interfacing, that will come about when we talk about Ether channel in another couple of chapters. If I want to reset the trunk to the default state, I simply go in there and I say no switch port trunk allowed, and then the VLAN, or no switch port trunk native VLAN, and that will remove it. If I want to reset the trunk to an access mode, I simply have to say, I go back into the interface, and I say switch port mode access, and again, the administrative mode is static, meaning we did it, and access. Now, DTP is Dynamic Trunking Protocol. It is proprietary to Cisco, meaning it was created by Cisco for use by Cisco. And it is on by default in your Catalyst switches 2960 and 2950. It is also set to Dynamic Auto as a default. It may be turned off with the non-negotiate command. It may be turned back on by setting the interface to Dynamic Auto. Setting a switch to a static trunk or a static access will avoid negotiation issues with the switch port mode trunk or the switch port mode access commands. So, your switch port mode command has optional or additional options. Use the non-negotiate to stop sending DTP negotiation requests. If you assign your port as access, it is in permanent access mode and negotiates to convert the neighboring link into an access link. The interface becomes a non-trunk interface, regardless of whether the neighboring interface is a trunk or not. This can create a problem because, think back to what I just said, both ends have to be configured the same. Dynamic Auto makes the interface able to convert. It will become a trunk interface if the neighboring interface is set to trunk or desirable. The default switch port mode for all Ethernet interfaces is Dynamic Auto. Dynamic Desirable actively seeks to become a trunk by negotiating with other auto or desirable interfaces. It will become a trunk if the neighboring interface is set to trunk, desirable, or Dynamic Auto. And then trunk is a permanent trunking mode and also negotiates to convert the neighboring link into a trunk. The interface becomes a trunk even if the neighboring interface is not a trunk, which also can create a problem because both ends of the connection have to be in the same mode. So the default DTP configuration is dependent on the Cisco iOS version and platform. To use or to see, you use the show DTP interface command to determine the current DTP mode. Best practice recommends that the interfaces be set to access or trunk and to turn off DTP. So as an administrator, if we know and we go in there and we configure ourselves, we know for certain that both ends are in the same mode. And that is idealistic, what we want.